guys, do you guys know that exam is tomorrow? No! It's okay. Let's focus. You know why? I found that the topic of logical equivalence might come out.
What? Why I don't know.
Seriously? Relax guys. Penny won't give you marks but knowledge might. So let me explain about this topic. So logical equivalence is two statements are considered to be logically equivalent if they have the same truth value. For example, we have to find if P by conditional Q is logically equivalent to P implies Q and Q implies P. We know that the truth value of P is true, true, false, false, and the truth value of Q is true, false, true, false. Next, we have to find P by conditional Q, which is true, 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 false, 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 true, false, and false, false is true. Next is P implies Q. True, true, we can get true, true, false, 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 true, true, and false, false is true. Next is Q implies P. True, true is true, false, true is true, true, false is false, and false, false is true. And the last one we have to find for P implies Q and Q implies P. True, true is true, false, true, false, true, false, false, and true, true, true. So we can see that the truth value for P by conditional Q is the same with P implies Q and Q implies P. So from this we can conclude that since P by conditional Q and P implies Q and Q implies P is identical, so P by conditional Q is logically equivalent to P implies Q and Q implies P. So, I have a few questions, so who wants to try first? Me! Aha!
So, for these questions, we need to show that whether these two equations are equivalent with each other or not. So, we need to use the truth table since the question mentioned it. So, for the true value for P, we know that it is true, true, and false, false. Same goes to Q, but it's true, false, true, false. For not P, is it opposite with the value of the original P, which is true and it becomes false. So, false, true, true. Same goes with not Q, false, true, false, true. So, we need to know that the not P and not Q for the true value is false, false, true, false. And for the P or not Q and Q, we know that the true value is true, 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 and false. And we put the not at the in front of these all equations, which is not in bracket P or in bracket not Q and Q. So we know that the true value is false, 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 true. And we proceed with the last of the equation, which is not P and not Q. So we get false, 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 true. So this equation, which is not P or not and Q and not P and not Q are identical. So not P and not Q is equivalent to not P or not P and Q. So that's it.
Next, who wants to try the next question? Me. Okay. For my question, express that P by conditional Q is logically equivalent to P and Q or not P or not Q using truth table. So as you can see, true value of P is true, true, false, false. True value of Q is true, false, true, false. Now we find true value of P and Q. P false, F false, FP false, FF F. Now we find the true value of not P. P false, false. We get false, false, P. For true value of not Q, we get false, true, false, true. For true value not P and not Q, we get false, 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 and true. Next, we're gonna find true value of P and Q of not P and not Q, we get true, false, false, true. For the next, we're gonna find true value of P by conditional Q. We get true, false, false, and true. As you can see, the true value of P and Q of not P and not Q is same with true value of P by conditional Q. So, equation not P and Q or not P and not Q is same with P by conditional Q are identical. Then equation P and Q or not P and not Q are logically equivalent to P by conditional Q. Anyone else who wants to try?
Me! So our next question is determine whether in bracket P or Q and not R is logically equivalent to in bracket P and not R or in bracket Q and not R using a truth table. So the truth value for P is true, 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 false, 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 false. Next, we have Q. The truth value for Q is true, true, false, false, true, true, false, false. For R, true, false, true, false, true, false, true, false. For equation P or Q, the truth value is we have true, 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 false, false. For equation not R, we have false, true, false, true, false, true, false, true. So we have in bracket P or Q and not R, the truth value false, true, false, true, false, true, false, false. Next, we have P and not R. The truth value of P and not R is false, true, false, true, false, 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 false. Next, we have Q and not R. The truth value for Q and not R is false, true, false, 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 true, false, false. The last one is we have in bracket P and not R or in bracket Q and not R. The truth value of them is at false, true, false, true, false, true, false, false. So if we look at the equation, we need to see if in bracket P or Q and not R if it is logically equivalent to in bracket P and not R or Q and not R using a truth table. So these two have the same truth value. So we have the final answer. So in conclusion, the P or Q and not R have the same truth value with P and not R or Q and not R. And P and not R or Q and not R are identical. So P or Q and not R is logically equivalent to P and not R or Q and not R. That's all.
Alright, for the last question, who wants to try?
Anna.
Yes.
For my question, we should determine whether not bracket R or S equals to T is logically equivalent to bracket R or S and not T using a truth table. So we should find a truth table truth value for R, S, T. For the R, E, T, 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 F, 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 F. For the S, E, T, F, F, T, T, F, F. For the T, TF, 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 TF. So we should find ROS. ROS, TT, T, TT, T, TF, T, TF, T, FT, T, FT, T, FF, F, FF, F. For the next one, ROS not implies to T, TF, 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 TT. For the not ROS implies to T, FT, 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 FF. And we find not T, FT, 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 FT. And finally, we find the ROS and not T, FT, 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 FF. So we can see, as you can see, this and this is identical. So they are logically equivalent. So not bracket ROS implies to T, and ROS and not T are identical. So not bracket ROS implies to T is logically equivalent to ROS and not T.
Alright guys, you guys are very clever and I hope that we can do our best for the exam tomorrow. Yay!
This is library.
Finally, we can conclude that truth table help us verify the logical equivalence between two statements that have identical values, and also help we can understand the difference between four conditions in the condition verbalization and also three conditions for only if condition. That's all from us. Thank you.